back. We're continuing problem number 1, and we're going to now answer questions A through F based on the graph that we drew in the first part of the video. So question A, where does the softball hit the ground and how can you tell? Well, first of all, this path represents the actual path that you hit when you throw the thing. So just imagine that Martin, the guy in the story, is down here on the ground at a height of 0. Here's Martin. And for some reason, I don't think it's throwing it because look at the height. It starts at a height of 0. So I'm going to say that Martin has magical powers and he kicks the softball because it starts at 0 up in the air from 0, goes up in the air, makes a parabola, comes back down and hits the ground again right here. So it's more of a physical sense. So this point is where the softball hits the ground, which that location would be, it hits the ground, you could say it hits the ground 10 feet from Martin. You could say it hits the ground at 10, 0 and give the location. There's different ways to say where it hits the ground. So I'm just going to, instead of writing my answer here, I'm just going to say that you can have two different forms. Either say that the softball hits the ground 10 feet away from Martin, or say the softball hits the ground at 10, 0, giving the location of that point. Those two answers are acceptable. And then, how can you tell? Well, I would say I can tell because the height of the softball at that point is a height of 0 on the y-axis, and that's how I can tell it's the ground. The grounds are height of 0. So that's part A. Part B, identify the x-intercepts. Again, this is just looking at the graph. Where the ball hits the ground is one x-intercept, and that location would be 10, 0, so I'll write that in here. 10, 0 is one of the x-intercepts. This is a comma, not a point. Now there's another x-intercept, which is right here, which is where Martin picks the ball from, or throws it in theory from the ground. So that location would be 0, 0. So there are two x-intercepts, 0, 0, where Martin throws or kicks the ball from, and 10, 0, where the ball finally hits the ground. The y-intercept happens also to be 0, 0, because the graph is touching the y-axis way down here at 0. So 0, 0 is also the y-intercept. For part C, find the line of symmetry. Earlier we have graphed it, it's right here. This vertical line that cuts the parabola into two equal pieces, that is the line of symmetry. And the equation of this line would be, since this line hits the x-axis, it's an x equals equation. If it was going the horizontal direction, it would be y equals. In this case, it goes through x equals 5, so that is the equation of that line. So x equals 5 is the line of symmetry. Find the vertex. That's up here at this point. This is the vertex. That's the highest point the parabola ever goes. And that location is, the x-coordinate was over 5, so it's 5. And then the y-coordinate was a height of 25. So 5, 25 is the location of the vertex. And you can write that down here, that 5, 25 is the location of the vertex. What information does it tell you? Well, think about it. What's the physical significance of this point here? Just like in real life, not just in math. I would say that it represents the highest point that the ball reaches in the air. That's it. That's as simple as it needs to be. So the vertex represents the highest point reached by the ball. You can write all that stuff down. Next, part E. What is the ball's horizontal distance from Martin when it's 24 feet up in the air? So let's first find out, where is the ball 24 feet up in the air? So let's go up there first. All right, here's a height of 24. So at this height of 24, the ball is in well, on its way up, the ball's here. And what is this horizontal distance? Well, count 1, 2, 3, 4. So the ball is 4 feet horizontally from Martin when it's 24 feet up in the air. That's one possibility. So down here, again, you need to write this in sentence form. I'm just going to put quick answers because the videos can only be 10 minutes on YouTube. So either the ball is 4 feet horizontally from Martin when it's 24 feet up in the air, or The other possibility is when the ball comes back down and it hits 24 feet again, now it's going to be 1, 2, 3, 4, 5, 6 feet horizontally from Martin. Remember, horizontal, like the horizon, goes this direction, and vertical, like an icicle, goes up and down. So we're 6 feet horizontally from Martin down here. So either 4 feet or 6 feet. You need both answers because they're both correct. Does this make sense? I would say yes. Again, you need to write this in a sentence. I'm just going to discuss it. Yes, that makes sense because the ball goes up and hits a height of 24. It goes 1 foot farther to reach a height of 25, and on its way back down, it hits a height of 24 again. So it makes sense that there are 2 points because what goes up must also come down. And finally explain, well, I just did. What goes up must come down. Write that down. For part F, do any of your data points not make sense? I would say so. It's either something special's happened or something's kind of off here. I'm assuming the ball hits the ground right here. But in our table, we had 11 comma negative 11. That doesn't make much sense. That would mean that the ball reaches a height of negative 11. That's 11 feet below the Earth's surface here. So one of 2 things is happening. Either this point makes no sense, and we can say that, or you could say, oh, interesting. The ball, in fact, didn't hit the ground. It hit the ground and tunneled through some sort of beaver hole here, or gopher hole, and ended up 11 feet below the ground. And it's kind of your choice. When it says explain, you can just choose a position. You could say, you know what, this point makes no sense because you can't go below the ground. Or you could say, the softball was, a burning meteorite, and in fact it hit the ground, but then it burned a hole 11 feet below the ground. Either choice is yours, and they're both fine as long as you explain your position. So that's problem 1. I'll continue with problem 2 in the next video. See you soon.